For this problem, let's take a look at this limit. The limit as x approaches -2 of x minus 3 over x squared plus 4x plus 4. The first question to ask is, can we directly plug in -2? The answer is no. If we plug in -2, we would get 4 minus 8 plus 4 equals 0 on the bottom. And so plugging in -2 would give an impermissible answer. So we know the answer, it blows up. The question is the answer, can we definitely say the answer is infinity or negative infinity, or can we not answer it because it depends on which side it comes from? So to do this, we'll write this as the limit as x approaches -2 of x minus 3 over x plus 2 quantity squared. And to investigate this, well, I'm going to do this in multiple approaches. Not all of these have to be shown on the exam, of course. This is mostly for review purposes to remind us of how things are going. So one way to look at this is numerically. Okay. Suppose I plug in like something that's very close to -2, like -2.000001. Okay. Then I would get that this is the top would be equal to -5.00001 over, and on the bottom, I would get -0.000001 squared. And so if I plug that into my calculator, sorry, start over again. So negative 5.1234501 divided by -0.1234501 squared, I would get a fairly large number. That's going to be on the order of -5 times 10 to the 12th. And so I -5 trillion. And so this is blowing up and blowing up positive. Likewise, if I plug in something that's a little bit to the right of -2, so -1.999999, so that's a millionth more than -2. Then I would have -4.999999 divided by 0.123 451 squared. And this would be approximately equal 5 times 10 to the 12th once again, or -5 times 10 to the 12th once again. So it looks up, it's blowing up and blowing up negative in both directions. And so that suggests that the answer is going to be negative infinity. Okay, so that's one way to kind of guess as to what's happening in this problem. A more algebraic way of doing it I can write it like this. The limit as x approaches -2 from above of x minus 3 over x plus 2 quantity squared. Okay, so if I plug in -2 into this, on top I would get -5. On the bottom, if I plug in something that's a little bit bigger than -2, I would get something that's a little bit bigger than 0 on the bottom. So I'm dividing by 0, but 0 in a positive sense squared, and that would be equal to negative infinity. Same idea if I take the limit as x approaches -2 from below of x minus 3 over x plus 2 quantity squared. Then I would again have a -5 on top. I would again have a 0 on the bottom, but this time it's 0 in a negative sense squared. So if I have a 0 negative, that's squared, that's going to be positive. Negative over positive is negative infinity. And so because of this, they're both the same direction. I would conclude that the limit as x approaches -2 of x minus 3 over x plus 2 quantity squared is equal to negative infinity, because these are both the same. All right, now if the idea of looking at these 0 pluses and 0 minuses are not terribly comfortable, I don't particularly blame you. And so another way of doing this is basically called a sign chart. Okay, so in a sign chart, we'll take a look at x minus 3 and x plus 2 squared. These are the two parts of the fraction. The points, and so we'll take a look at the quotient, f of x at the bottom. And the points of interest are going to be -2 and 3. For the top one, if I plug in 3 into x minus 3, I get 0. If I plug in something bigger than x minus 3, I get something that's positive. If I plug in something that's less than 3, I get something that is negative. X plus 2 quantity squared. If I plug in negative 2, I get 0. If I plug in anything else, because I'm squaring it, I get something that is positive. Okay, now we analyze. Negative divided by positive is negative. If I divide by 0, I get a vertical asymptote. Negative divided by positive is negative. 0 divided by positive is 0. Positive divided by positive is positive. And so what I care about the most in this little diagram is what I see right here. To the left of negative 2, the graph is going to be negative going to this vertical asymptote. To the right of negative 2, it is also going to be negative going to the vertical asymptote. And that's exactly what I see on these two lines here. And therefore, I also concluded that the limit as x approaches negative 2 of x minus 3 over x plus 2 quantity squared is equal to negative infinity. So this is a sign chart approach. For the purpose of the exam, probably the approach in purple or the approach in black would be the most time efficient. Pick the one that makes the most sense to you. They're both logically equivalent.